Lesson 12.4, Angle Measures and Segment Lengths. The first new vocab word that we're going to look at today is a secant. A secant is a line that intersects a circle at 2 points. So line AB in this example would be a secant. Here's a rule about a secant. Theorem 12.3. An angle formed by two secants intersecting inside the circle is calculated by half the sum of the two intercepted arcs. So looking at our picture, we have two secants. I'll call this one line 1 and line 2. Line 1 and line 2 have this intersection point and they form angle 1. These intercepted arcs, x and y, if we add them together and take half the sum, that'll give us angle 1, and then the angle over here would also end up being the same. That's the rule we're going to explore. Theorem 12.4. An angle formed by two intersecting lines outside the circle is calculated by this formula, half of the difference. So the picture over here was the intersection is inside the circle. On the next page, the intersection of the lines is outside the circle. So if our intersection is outside the circle, we subtract the red angle x from the blue arc y. So red minus the blue, take half. Red minus the blue, take half. So here are the two rules side by side. Notice when the intersection point is inside the circle, the formula shows half the sum of the intercepted arcs. In the second diagram, if the intersection point is outside the circle, we do the larger arc minus the smaller arc. And this second scenario can happen in a couple of ways. In this first example, we have two secants. In the second example, we have a tangent and a secant. In this third example, we have two tangents intersecting. They will all have that same formula where subtraction is used. So let's try an example. Question says, what is the value of each variable? So we look at the intersection point. X is on the inside of the angle, so we're thinking about half the sum. So we take the angle x is going to equal half of 90 plus 46. Simplifying that, add those two together and then multiply to get half. Our answer is 68 degrees. Second question, the intersection is outside of the circle, so we want to do half the difference. Remember, we want to do the larger arc minus the smaller arc. So in this case, that's going to give us 95 minus z. And then we have a little bit of algebra to do versus the first question. So instead of distributing to the 95 and getting a decimal, I would like to double both sides to get rid of that fraction, because half of 2 will cancel and leave us with 95 minus z. On the other side, we get 40. Then we subtract 95 from both sides, and we get a negative 55 equals a negative z, which means z is equal to 55. On the next slide, the intersection is on the outside of the circle, so you ask yourself, do I add the arcs or subtract them? You're right, we subtract, remembering to do the larger arc minus the smaller arc. So 70 degrees is equal to half of w minus 110. We want to isolate the w. So my first step is to double, and we get 140 equals w minus 110. Doubling got rid of that half. Then we can add 110, and our answer is 250. The next example, intersection is inside the circle, so we're thinking about half of the sum. So we're going to add x and 30 degrees. Again, doubling to get rid of the half. And we're left with x plus 30. Answer, 40 degrees. Pause the video and try the last one on your own. Here's the answer. Our intersection is outside of the circle, so we want to do half the difference. 110 is the larger arc, so we want to do 110 minus 30. And then we can just simplify from left to right. Answer is going to be 40. Let's try a word problem. A satellite orbiting above Earth's equator has a viewing angle of Earth formed by two tangents to the equator. The viewing angle is about 17.5 degrees. What is the measure of the arc of Earth that is viewed from the satellite? So there's the satellite hovering above the Earth. We want to know how much of the Earth can it see. So it can see from point A all the way to point B along this entire arc. And the measure of that angle is 17.5 degrees of viewing space. We want to know what is the measure of this viewable region. So for us, I think we need to define what this orange region is and what this green region is, because we don't really have a starting point. So I'm going to call the orange X, and if the orange is X, we have to decide what the green would be. Well, orange plus green is 360, so I think we could call the green 360 minus X. Here's why I could call that 360 minus X. We know that orange plus green is 360. We'll call the orange X, we'll call the green Y. So X plus Y is 360. If I get Y by itself, I get 360 minus X. We don't want to have two variables in our equation. So instead of calling this Y, we're now going to call it 360 minus X. So looking at our picture, this intersection point happens outside of the circle, so we want half of the difference. So we want to do the green larger arc minus the small orange arc. So setting that problem up would look like this. 17.5 is going to be equal to half of the green arc, which is 360 minus X, minus the orange arc, X. So then what we can do is simplify. So I'm going to start out by doubling to get rid of my fraction. So 17.5 turns into 35. And we get 360 minus x, which I can simplify to minus 2x. And I think we can work with this. We can subtract 360, and we get negative 325 equals negative 2x. Dividing by a negative 2 will give us a positive 162.5 degrees. So we knew just by the look of this that it was going to be less than 180. So 162.5 degrees is the amount of space we can see on that Earth. So when we were setting up this problem, it was important for us to call this smaller arc X instead of switching it around and calling this side X and this side 360 minus X. If we did that, that would make our problem a lot harder, because then we'd have to do X minus the orange, and our problem might look like this, which is going to give us some sticky algebra in here, where you'd have X minus 360 plus X inside the parenthesis, and then you'd have 2X minus 360, and then when you're finished solving this, it's actually going to give you the green arc, and then you'd have to subtract from 360 to get the orange arc. And the orange arc was the arc that we wanted for our answer. So be careful on a question like this. You'd want to name the arc that you're trying to find X, and then figure out what the unknown portion would be in an expression. This concludes the first half of Lesson 12.4. I have a quick reminder. Here are the rules that you need to remember. The new rule today was if it intersects outside the circle, it's going to be half of the difference. Outside the circle, half the difference. Outside the circle, half the difference. So in this first example, this is two secants. The second example is a secant and a tangent. And the third example would be two tangents. So these are just three different cases for that same rule.